Under the subject of quality, reliability and engineering of a degree semester 7 mechanical engineering department, today we are going to see experiment number 7, which is to study about Taguchi method. So first let's understand what this Taguchi method is. A Taguchi method was developed by Genichi Taguchi. It is a statistical approach to improve the quality and performance of a product or processes. It emphasizes on a robust design, that is, designing the product and processes in such a way that it can perform consistently under varying conditions. Means here it is said that noise factor. Noise factors are the factors which are not under the control of a system. So that is why it is called noise factor. So the basic idea of robust design is that the product or processes are designed in such a way that even after the uncontrolled factors are involved in the system, still the system or the product will perform its function in an effective manner. So this is a robust design. So in manufacturing, Taguchi methods are widely used to minimize variation, improve quality and reduce cost through systematic experimentation. So let's see the principles of Taguchi method. So Taguchi philosophy is based on first design of experiment, means conducting the controlled experiment to study the influence of multiple variables. Second, robust design, as I just discussed, making the product or process insensitive to the external variations. Third is signal to noise ratio. It is a measure to identify the base settings that minimize variability. Then orthogonal arrays, a structured method to plan experiments effectively and efficiently with fewer trials. Key concepts means the factors, or you can say the parameters or the terminology involved in the Taguchi method. So first is the control factors. So the control factors are the factors or parameters that can be adjusted or controlled, that like example temperature, pressure, speed. These all variables we can control. Second one is noise factors, means uncontrolled variation. We cannot control these. So like humidity, material inconsistency, these are the noise factors. Then orthogonal array. Orthogonal array are a predefined matrix used to systematically test combination of factors and labels. Signal to noise ratio. Statistical measure to identify settings that yield consistent performance. Then loss function. It is measure of a quality loss as a deviation from target value increases. Means if there is a particular target value and your process is performing away from that particular target, so how much loss you will incur or how much loss the organization has to bear. So this will be calculated based on this loss function. Let's see the steps in Taguchi method. So first, identify the problem and define the performance characteristics or a response. Second, select control factors, means the factors which you can control like machine speed. For example, we are deciding the levels. For machine speed, here the levels are low, medium and high. So select the control factors and their levels. Then select the appropriate orthogonal array like L9, L16. These are based on the number of factors and number of levels. Then conduct these experiments, calculate the SN ratio for each trial, analyze the results to determine which factors have the most significant effect, determine optimal levels of control factors, validate the experiment by conducting the confirmation runs. Let's see the applications. In machining processes like turning, milling, drilling, optimization, in all these manufacturing or machining processes, we can decide the optimum value of the different process parameters involved in these machining processes. Then welding parameter, current, voltage, speed, these are the factors or you can say control factors which we need to find the optimum value. So we have a maximum a good parametric welding. Then casting and molding to improve surface finish or dimensional accuracy. Heat treatment processes to improve hardness or strength. Design optimization in product development. So this all are the factors, or you can say the areas or applications where we can implement the Taguchi method. Now let's understand by one example. Here the objective is we want to improve the surface finish in turning operation, and for that we have this much control factors: cutting speed, feed rate, and depth of cut. Means we have three control factors for improving the surface finish in turning operation. So let's see, the orthogonal array is L9, means we are taking three factors, that is cutting speed, feed rate, and depth of cut, and we are taking three levels, means we are taking three levels of cutting speed, three levels of feed rate, and three levels of depth of cut, and that is why this is called L9 orthogonal array, that is three factor by three levels. So by this carrying out this orthogonal array, the optimal settings we identified was that by keeping the high speed, low feed, and medium depth, the base surface finish can be achieved. So this is a simple example of a Taguchi method. Conclusion is, the Taguchi method provides a systematic and efficient approach for improving manufacturing quality through parameter design and optimization. Means we are selecting the control factors and identifying the which are the optimal value of these all parameters. By using this statistical design of experiment, it minimizes the number of trials while identifying critical factors influencing performance. For example, there are three factors and three levels we have taken, an L9 array we have selected. If we are not taking this L9, then we need to check the each parameters factors and levels differently, and each time we have to perform different operation. But based on this design of experiment, the number of trials will be reduced. So this is the one of the most significant benefit of using the Taguchi method. So it ultimately helps industries in producing high quality, cost effective, and reliable products that perform well under varying real world conditions, making it an essential tool for continuous improvement and robust process design.